Okay, so we've got them going. Now I have to do what? Make this full screen. Is this going to work here? Voila, there we are. That's as full as it gets, folks. So if you can't see in the back, there's lots of first class seats up here in the front. If this was a basketball game, these seats would all be filled up. Because it's math, it's like, math is not contagious, people. It won't hurt you. It won't infect you. Just move on a little closer. If you're having trouble seeing, there's some seats over there. So if you can't see well in the back, there's the screen over there, a screen over here. And I'm going to stand here and talk about it. And I'm going to keep moving this way because I have to be on the camera for the people online. So if I get in your way, just ask me to move over a little bit. Okay, we're on page 10. And you read from Canvas the announcements and things and the syllabus and stuff that we work the even ones in class to show you how to do it. And then you work the odd ones for homework. But the beauty of the homework is that after you've worked it, you get immediate feedback to see if you missed it or not, because you turn to the back of the book and you grade your answers. And if you missed it, just put a check mark by it and say, I missed it. Then go ahead and grade your whole assignment. And then when you're finished, come back and look at the ones you have check marks by and see if you can figure out why you missed it. And if you can't, you can send me an email and say, I missed this one and I don't know why. Or you can come to class early. I get here at 7:30 every morning to be here to answer questions for you. And I'm here available after class. This class ends at about 9 o'clock. And your next class doesn't start till 9:30, so I'm available for 30 minutes after class to answer questions. And what happens is, after class, if you stay, if you so your homework that you're doing for today that you'll turn in on Wednesday, if you don't understand everything, then you can just come up here to the front row after class on Wednesday and I'll help you finish your homework, and then you can just turn it in. And then you turn your homework in and you get credit for it. It's not late because you're trying to understand math. And if you don't know why you missed it, then you come up here and I'll help you with it. And the people online, they just send me an email and tell me what they're having trouble with, and I send them an email and tell them how to get unstuck, hopefully, and move on with it. And be sure and show your work. I mean, it's pretty obvious that if you just show the answers on your paper, I can't tell whether you just copied them from the back of the book or you worked them out. So be sure and show your work. Just like here's how I'm showing my work for problem number 2. What do the letters in RSTUV stand for? And I put out here page 3. That's where I found it. Maybe I should change this to red so we can highlight some things. I put page 3. And what does page 3 say? What's R stand for?
Read.
Read. What's S stand for? What?
Select.
Select. What's T stand for?
Think.
Think. What's U stand for?
Use.
What?
Use.
And what's V stand for?
Verify.
There you go. And you got it from page 3. Question number 4. What is web query? And you go, I don't know. And then it says, then I said for number 4, I say, look at page 10. What is web query? Bottom of page 10.
Research service.
Web query is a research service. Oh, all you have to do is just look at the book to find the answers to questions. You go, you mean I'm not supposed to know what web query is in the back of my mind from all the math I've studied before in life? No. You just look this stuff up and figure out what they're talking about. Some things I'll expect you to know. What's 3 plus 4? Let's try that again. On the count of 3, everybody say the answer. What's 3 plus 4? 1, 2, 3.
7.
Okay, you're in good shape. You've come here with the proper mathematical background. Maybe not. What's 3 times 4? Well, some of you came here with the proper math. No, you know how to. What's 3 divided by 4?
0.75.
Ah, thank you very much. I got a mathematical man back there who's on my channel. And the rest of you are going, you guys enjoying this stuff? Yes, we are. 0.75. Don't you have a little calculator floating around somewhere in your head? You go, nope, only math people have that. Then you need to get one. In fact, I brought one with me just in case I need one. So I'll just pull it out and put it down here, just in case I need it later on. I can pick it up and do a little math with it. You go, no, you're old school. I have math on my phone. Yeah, but you know what's going to happen? When we get to the place where we're doing square roots, your phone won't do square roots, will it? Oh, yours does? Last semester, some people's phones wouldn't do square roots. So you might need to pick up one of these things for a couple, $3 at a store somewhere. Okay, so what does question 4 say? What's web query? It's a research service. How many membership plans are available? 3. There you go. We just answered question 4. Question 6. If you're in the light use plan, see it there right in the middle of the 3 plans? If you're in the light use plan and you make 15 transactions in a given month, so see what I do? I go light use and 15 transactions. See, I look at what the book says when I'm reading these math problems, and I extract from there the information I'm going to need to work the problem. So I'm kind of taking all those words and summarizing it into a few short bits of information that I can use to do some math with. Light use, 15 transactions. What else does it say? What's your total cost? Oh, total cost. Didn't put that down there. Well, now I will. Well, let's see. How do I calculate light use? The monthly fee is $1.95. You see that? And you get how many free inquiries? It's not free. You paid $1.95 for it. But how many of them do you get before they make you start paying? 10. So you take the total, the 15, minus the 10. And what's 15 minus 10? 5. Everybody see that? So I take 5 times, what do they charge me for everything over 10?
15 cents.
15 cents. Everybody see it? Say, how does he know that? He's looking at the blue stuff on page 10. He's just looking at what it tells you there and looking at the chart and reading the chart and figuring it out. So then I take 5 times 15 and I get 75 cents. And I add 75 to $1.95. And what's the total charge? $2.70. That's a funny looking 2. There you go. $2.70. See how you work them? And you see how I showed my work here? I just wrote down what I'm doing while I'm doing it. I started to turn the page. See, I'm still a little behind technology-wise when I just have to scroll up to number 8. What does number 8 say? What's the maximum number of calls you can make in the occasional plan, OP, and come out spending less than which plan? The light use plan. See how I wrote that up there? I want the occasional plan total to be less than the light use plan. Well, what's the occasional plan? There's no monthly fee. It's just 20 cents a transaction. Everybody see that? So I said, so now watch. I'm not looking for a mathematical formula. I'm just trying to figure out which plan's cheaper. So I said, what if I made 20 calls, 20 transactions? I just pick a number. You could say 100, you could say anything, but I just picked 20. What's 20 times 20? $4? What if I make 20 transactions over here with the light use plan? Let me scroll it over where you can see it. It's $1.95 plus 20 minus 10 times 15. That's $3.45. Everybody see that? You see where I got the $3.45? If you don't, now let's talk about it. Remember, I took the 20 calls I picked minus the 10 that I don't have to pay for because I paid it with my $1.95. So I have 10 left times $1.50. So that's what, $1.50? What's $1.95 plus $1.50? $3.45. Well, I want the occasional plan to be cheaper than light use. And here the occasional plan is more than light use. It's $4 and this one's $3.45. Did I make a mistake in arithmetic here? Okay, check me out because sometimes I make mistakes. So if you do the math, if you take $1.95 plus 20 minus 10 times 15 cents and you get something other than $3.45, speak up and let's talk about it. So then I said, okay, so what if I made 10 transactions in a month? Then it would be $2 here, you see that? And it would be $1.95 over here. Aha! If I make 10 transactions, then I'm better off with the occasional plan. Because, no I'm not. I'm still too much. This is $2 and that's $1.95. So I'm going, okay, I'm pretty close. Let's jump down to 9 transactions. See how I'm just working my way down, trying to get close to where I'm trying to find where the occasional plan is going to be less than the light use plan for the number of transactions. And I'm going, that would be $1.80. But the light use plan would still be, if I only made 10, it's still going to be $1.95. So it looks like it's cheaper. What was the question again? See, I come back and look at the question. Which problem is this, number 8? What's the maximum number of calls or transactions you can have? And that would be 9. Everybody see that? And see how I show my work here? All right. Well, I think we're on our way. Now, there's a real fancy way to work this, using variables and inequalities and solving the inequality. But I'm just not inclined to do it that way on a normal basis, as much as I like math. There's a problem-solving strategy that I like to use as well as I like to teach, and it's called trial and error. And you're more apt to use that in your life and problem solving in the future than you are solving an inequality mathematically. And if you know how to do it mathematically, you're welcome to go ahead and do that. I'm not going to take time to do it. If you want to see it after class, stick around and I'll show you how to do it just for fun. But this to me is a more useful and practical way to do problem solving. Number 10. So what does number 10 say? If you expect to have 50 transactions in a month, so I'm going to have 50 transactions in a month. What's it want to know? Which plan should you select? Well, I'm assuming I should select the one that's cheapest. You say, no, I'll pick the high-priced one just for the fun of it. No, they want you to pick the cheapest plan. So I put all 3 plans up here: the occasional plan, the light use plan, and the standard plan. You see all of them there described? Let's scroll up here and see what happens. If I make 50 transactions with the occasional plan, it's going to cost me $10. You see that? If I make 50 transactions with the light use plan, it's going to cost me $7.95. Everybody see how I got the $7.95? I took the $1.95 charge plus 50 minus the 10 that I don't have to pay for. That's 40 times 15. That's $6 plus $1.95 is $7.95. Okay? Then over here, the standard plan, hey, you pay $9.95 for anything under 100 transactions. So which program would you say I need to be on if I'm going to have 50 transactions a month?
Light use.
Thank you, the light use plan. Just checking, see if you're all with me. You go, yeah, I'm with you. It's just, it's 8:20 in the morning. Who ever thought of having math this early in the day? I raised my hand. I don't know why people don't like to get up early in the morning and do math. That's when your mind is freshest. You go, at 8:20, my mind is not fresh for anything. Oh, just work at it a while. You'll get used to it. Okay, number 12. Okay, in problems 11 through 20, now see, they're telling you what they're going to do here. They're going to do inductive reasoning in case you wonder. But they want you to identify the pattern and find the next three terms. So they give us 2, 5, 10, and 17. And they say, so can you figure out what these are? And your answer is, sure. Are some of you thinking, I have no idea? Well, let me show you how you get there from here. First, how did you get from 2 to 5? How did you get from 5 to 10? How did you get from 10 to 17? How do you get from 2 to 5? I mean, mathematically, there's only 4 things you can do. Add, subtract, multiply, or divide.
Plus 3.
So what?
Plus 3.
You plus 3. Everybody see that? Then how do you get from 5 to 10?
Plus 5.
You plus 5. You go, that's not helping me. How do you get from 10 to 17? Plus 7. See, you just have to keep going. It's called perseverance. Oh, and see, if you quit after the first two, I have no idea how to do the next one. As soon as you've done 3 of them, all of a sudden, your mind goes snap, just like a trap. Now, how do I get the next number? I went plus 3, plus 5, plus 7. I'll bet I'm going to go plus 9. And what's 17 plus 9?
26.
Whoa! Is this powerful or what? What do I add next?
11. 37.
3, 5, 7, 9. Then what?
11.
Plus 11. And what's 26 plus 11?
37.
See, the only way you can mess this up is make a mistake in addition or something. And then after 3, 5, 7, 9, 11, then what?
13.
Plus what?
13.
Does everyone see where they're getting those numbers? See, your mind just goes there. Once you've got enough things down, so what's your, see, that's why they say, find the pattern, or identify the pattern. It isn't like you know it already, but you put up enough stuff to where you see the pattern, you go, oh, there's the pattern. And God wired us in such a way, He gave us minds that are just kind of scanning, looking for patterns. And when you see it, you go, aha, there's the pattern. 3, 5, 7, 9, 11, 13. Oh, so what's the next one after 37?
50.
50? Is that right? And if you put it down and check it in the back and you missed it, you go, check it wrong, then come back and look at it and say, oh, I added wrong. When I added 13 and 37, I came up with 40. How could you do that? It's called total depravity. Some people think that when Adam and Eve messed up big time in the garden and got kicked out, that it only messed them up spiritually. It messed them up mathematically too. And that's why some people don't like math. It reveals the depth of your depravity. And when you make a little mathematical mistake like that and go, 40, why did I say 40? You just forgot to add right because you were doing it in your head and you just, and you felt good about it. I mean, excuse me, 50 looks too big anyway. You understand? In my heart of hearts, 40 seems like a better answer. Well, go ahead and follow your heart and see where it leads you. Do you know the Bible verse for that one? It's deceitful and desperately wicked. Come on, people. Think it through. Check the facts. And just don't get all worked up and bent out of shape. And don't be offended when you discover just how totally depraved you are. We're all in the same boat. And that's why sometimes when we're working these problems and I make a mistake, students just smile. They love to see the math teacher's depravity come oozing out of it. Hey, it's just life, and it's going to happen, and I know it is, so I don't get worked up about it. Okay, number 14. Now do you see what we're doing here? And see, we're going to do the even ones, and then you're going to go back on your own and do the odd ones, and you'll get it figured out. Number 14, what did they do for number 14? They have 3, 3, 3, 3. So it looks to me like those blanks are going to have 3s in them, aren't they? But it was 3 to the first, second, third, oops. I started to say first, second, third, fourth. See, I'm looking for a pattern. No, it's first, second, fourth, eighth. So what's the next one?
16.
16. Where does that come from? Well, okay, add, subtract, multiply, or divide. We're not adding here. So from 1 to 2, you take it times 2. And then times 2, and you get 4. Times 2, and you get 8. So times 2, see that? And you get 16. So you have to figure out which operation you're going to use to get to the next number. Oh, so if this one's 16, what's the next one? For problem 14. What?
32.
32. And what's the next one?
64.
64. Everybody follow what's going on? Good. Let's move down to number 16. Whoa, what do we have here? 16 is a disgusting problem. And I'm glad it's an even one instead of an odd one, so you wouldn't get mad about this stuff later on. Okay, now what are we doing? Looking for a pattern. Okay, how did I get from here to here with that little shaded square? Well, watch. I flip it once to get here, then I flip it twice. I flipped it twice to get it there. You follow me? Just flip it over, just flip it over, flip it over, flip it over, and I flipped it twice to get to the next one. Then how did I get from here clear down to here? I flipped it 1, 2, what? 3 times. To get from here to here, I flipped it 3 times. Everybody follow that? Then how did I get from here up to here? I flipped it 1, 2, 3 times again. So the question is, what do I do next? Now see, here's why I don't like this problem, but I'm glad we're working on it in class. The guy who wrote the book put this together, and I'm thinking, that's disgusting. If this would have been a 3, then the pattern would be what? Just flip it 3 every time? But because he made it a 2, I don't know whether it's supposed to be 2, 3, 3, and then 2, 3, 3 again, or whether it's supposed to be just 2 the first time and then 3, 3, 3, 3, 3, 3. Right? He didn't give me enough information to discover the pattern. And I'm going, well, you would think the guy who wrote the book was a mathematician. Why would he confuse me like that? So I thought, well, I'll find out what he was thinking. I'll look at the answer key. You say, well, there is no answer for the even ones. You don't have an answer for the even ones, but I do. So I picked up my big thick book and turned over there and looked at the answer key. I couldn't believe it. Answers will vary. Yeah, they'll vary because you weren't clear in the problem you put in the book, knucklehead. Why didn't you just make it clear whether it's 2 or 3? Because you see, some people are going to go 2, 3, 3, 2, 3, 3, and others are just going to say, no, it's 3 every time. So for some reason, the guy who wrote this book said, I'm going to tell them to discover the pattern, and then I'm going to put one in there where there are 2 choices for a pattern. And the 2 choices give different answers. Now, I love math, but I want to send him an email and say, shame on you. That was not kind to do that to my head. But just understand that sometimes that happens in life. Fortunately for you, number 15, the one you have to work, Look at the picture on page 11 for number 15. How do you get from the first blue square to the second one? How many times did you flip it? How many times did you flip it next? Twice. How many times next?
3 times.
Ah, now I see that pattern that I was looking at. 1, 2, 3. So how many times do you flip it next?
4.
4 times, and then next 5 times, and next 6 times. Question?
No, I was just saying.
Okay, yeah, okay. So do you see what you're doing? See, on the one that I work here in class, the answers vary. The answers aren't going to vary for number 15. It's all supposed to be the same because the pattern is perfectly clear. Okay? Number 18. What's number 18 say? Oh, some of my favorite numbers. What kind of numbers are these? Say, let's all say it together on the count of 3. What kind of numbers are these? 1, 2, 3.
Fractions.
Now see, some of you have an attitude already. I can tell by the tone of your voice. If I was a fraction, I would be offended by the way you made reference to me in this classroom. And I love fractions. And one of the reasons I love them is because everybody else seems to hate them. And I just feel sorry for them. They're friends of mine. I do like them. So I look at 1/14 and I'm going, that is so cool. But the reason a lot of people don't like them is when you were taught to do fractions in grade school, the teachers didn't make it perfectly clear. Some of the teachers didn't understand it, wasn't perfectly clear in their mind anyway, so how could they help you understand it? Or it just was so different than what you had done before and you don't like doing things a different way. You just got all worked up and bent out of shape and said, I hate fractions. Well, you don't have to like them to work with them, but here we are working some fractions. And 18 says, what am I doing now? I'm trying to identify the pattern and then find the next 3 terms. Well, for sure, I know the next 3 terms have a 1 on top. I mean, I can say that for sure, can't I? 1, 1, 1, 1, 1, 1. So now, what's going underneath? How did I get from 14 to 9? You say, what? Okay, 4 operations, add, subtract, multiply, divide. How would I get from 14 to 9?
Subtract.
Subtract 5. You go, I'm okay with adding up there, but I don't think I like subtraction. Okay, so now we found another thing. You don't like fractions, now you don't like subtraction. So just get over it. So how do I get from 9 to 12?
You
Add 3.
See, we like adding, so add 3, yeah. How do I get from 12 to 17?
subtract 5.
Subtract 5. You go, what? How do I get from 7 to 10?
You add 3.
See, I can tell some of you have already seen the pattern because once your mind latches on that pattern, I see a smile on your face. And I can't believe you're sitting in math class at 8:30 in the morning smiling about something. That is so cool that we're having so much fun doing this math stuff. So, do you see the pattern? Subtract 5, add 3, subtract 5, add 3. Now, there's probably a little voice in the back of your head saying, that's the dumbest pattern I've ever seen in the world. We're not here to make judgments about the patterns. We're just trying to find them and use them to find the next 3 terms. Don't be so judgmental. Just do the math. Do the math. So what do I do after I add 3? Then I subtract 5. Then I do what? Then I add 3. See what I'm doing? I'm just putting the stuff I'm going to do out here. Then I subtract 5. Do I have it right? So I added 3 to 7 to get 10. I take 10 and subtract 5, and what do I get? 5. And I have 5 and add 3, and I get what? 7?
8.
I thought 5 plus 2 was 7. 5 plus 3 is 8. There you go. And then I have 8 minus 5, and I get 3. Is that cool stuff? Are we having fun yet? No, that is not the word to use in math class. Okay. Let's go on down here to number 20. 6, 1, 9, 5, 12, 9, 15. Well, they gave us plenty of them. Can you see the pattern? How did I get from 6 to 1? Minus 5, isn't it? How did I get from 1 to 9?
You add 8.
Plus 8. How did I get from 9 to 5? Minus 4. Is that right? How did I get from 5 to 12?
You add 7.
Plus what?
7.
7. Do you see a pattern? You say no. Well, let's keep going. How do I get from 12 to 9?
Subtract 3.
Minus 3. How do I get from 9 to 15?
You add 6.
6.
Plus 6. Now see that? Here's minus 5, minus 4, minus 3. So what's going to be next? Ah, see? Your mind just latches onto it, doesn't it? Minus 2. And then I skip 1, and what do I put over here? Minus 1, right? Because it's every other one. Then this was plus 8, plus 7, plus 6. So what's the next one?
Plus 5.
Plus 5. So after 15, what's the next one? 13. And after 13, what's the next one?
18.
18. And after 18, what's the next one? Oh, do you feel powerful? This is so much fun. This is almost as exciting as watching the Chiefs win a football game, isn't it? Well, maybe not. Number 22. The first 10 triangular numbers are 1, 3, 6, 10, 15, 21, 28, 36, 45. Well, there you go. How did I get from 1 to 3? Add 2. How did I get from 3 to 6?
You add 3.
Add 3. How did I get from 6 to 10? What do you think we're going to do next? Add 5. Let's see. Sure enough, add 5. Then what? Add 6. Sure enough, 15 and 6, 21. Add 7. Add 8. Add 9. Am I doing it right? 3, 6, 10, 15, 21, 28, 36, 45. Then add what? 6, 7, 8, 9. Add 10. And then move it over, and then what? Add 11. And then add 12. And then add 13. How come I'm going, keep going? I don't know. Add 14 just because I'm on a roll and I know what I'm doing now. And then add 15. Okay. So, which problem is this? Number 22. Number 22A, find the difference between adjacent triangular numbers. I did that. See how you show your work there? That's A. What numbers do you get? 2, 3, 4, 5, 6, dot, 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 right? Just means it keeps going. 22B, find the sum between adjacent triangular numbers. For example, what's 3 plus 1? 4. I'll put that down here. Okay? What's 3 plus 6? 1 plus 3 is 4. You follow that? You add these two, you get 4. You add these two, you get what?
9.
You add these two, you get what?
16.
You follow what's going on? You following the instructions? You go, yeah, I'm looking at that other garbage you have written there. Well, it's just something to think about. So then I got 16, then I get these two added, 25. Does everyone see another pattern? the second one, the first one plus the second one is the same as 4. That's the same as 2 squared. See that? The third one squared is 9, which is the second one plus the third one. You follow what I'm doing? It just keeps working its way out there. So, following the pattern, find the sum of the 9th and the 10th triangular numbers. What would be the sum of these two numbers? It would be 10 squared. Agreed? The 10th number, what's 10 squared? 100. What's 45 plus 55? 100. You follow what's happening? 22D. Find the sum of the 14th and the 15th triangular numbers. That's why I came out here. The 14th and the 15th, what would that be? It would be 15 squared. Anyone know what 15 times 15 is? Get your calculator out and go 15 times 15, and you get what?
225.
225. Some of you have that memorized. Oh, it just warms my heart to hear that somebody has memorized that many of their squares, those perfect square numbers. Okay. So let's move down to number 24. See what I mean by showing my work? What's 24 all about? The figures represent the square numbers. Draw 24A. Draw the next one. What did they give me? 1, 2, 3, 4. They gave me 4. 1 squared, 1 dot. 2 squared is 4 dots. That's 4. 3 squared is 9 dots. And what's 3 squared? 9. 4 squared is 16 dots. 5 squared is what? 5 dots by 5 dots? 25. What do they want me to do? Draw the next square number. Oh, they just want me to draw the next one. I did that. What's 24B? Describe the pattern and list the next 3 square numbers. Okay, what's the pattern? The next 3 square numbers are 6 squared, 7 squared, and 8 squared, right? It didn't say draw a picture of them. If I did, I would have what? 6 dots wide and 6 dots high and fill all the dots in between? But they didn't say do that. They just say, what are the next 3 squared numbers? And that would be 6 squared, 7 squared, and 8 squared. Where'd we go? (24C). What's the 12th squared number? The 12th squared number would be what?
144.
12 squared, 144. You go, how do you get that? Take your calculator, punch in 12 times 12, and you get 144. He just happened to have it memorized. Somewhere in life, someone taught him that, and he just said, I just like these squared numbers so much, I'm going to remember them. Just like you remember your multiplication facts. If you don't remember it, then you get your calculator out and do the work. Number 26. The figure below shows the numbers of line segments that can be drawn between 2 points. So here's 2 points, and how many lines can I draw? 1. Here's 3 points, and how many lines can I draw? 3. You follow me? Here's 4 points. How many lines can I draw? 1, 2, 3, 4, 5, 6. 6. Everybody see that? Here's 5 points. How many lines can I draw? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like that's all of them, isn't it? So, do you see a pattern? How'd you get from 1 to 3? Add 2. How'd you get from 3 to 6? Add 3. How'd you get from 6 to 10? Add 4. See what's going on? So what am I going to do to get from here to the next one? Add 5. So that means there's going to be 15 of them over here. You go, no way. Okay. Take a piece of paper, make 6 little points on it, take your little ruler so it will look prettier than my picture does, and draw the lines, and sure enough, you'll find 15 of them. What do they want me to do for 24 anyway? See, I got so busy just messing with it, I forgot to read what they want me to do. Or 26, I mean. How many line segments can be drawn with 6 non-collinear points? 15. 9 non-collinear points. Okay, that would be 7, 8, 9. This would be, it was plus 5, then what would it be now? Plus 6, and then plus 7. Is that right? 4, 5, 6, 7, then plus 8. So I take 15 plus 6 and I get 21. 21 plus 6 is 28. 21 plus 7 is 28. 28 plus 8 is what?
36.
36. See what's going on? You see, finding the pattern is much easier than drawing all the pictures and counting the lines. But if you want to, you could draw the pictures and count the lines. 28. What's 28 have us doing? Oh, this is so much fun. Select a number. Somebody say a number.
10.
10. Somebody else say a number.
55.
What?
55.
35?
I said 55.
I didn't hear you.
55.
55. I don't want to misrepresent you here. 55. Somebody else pick a number.
294.
What?
294.
You put that one on your paper. You go ahead and put that one, because it says, 28 says, follow the procedure for 4 different numbers. How about 2 and 6? I mean, you pick the numbers. Then we do what? Okay, we add 7, that's 17. Then we times 3, that would be what? 51. Then we subtract 6, that would be 45. Then we divide by 3, that would be 15. Then we subtract 5, that would be 10. Well, let's try it with 55. Add 7, what do you get? 62 times it times 3, 186. Subtract 6, 180. Divide by 3, 60. Minus 5, 55. 2, add 7, what do you get?
9.
Times 3,
27.
minus 6. Divide by 3, minus 5, 2. Everybody see what's going on? See how I'm showing my work here? What was that number you're going to work on your assignment?
294.
294. Good for him. And all the rest of these are the same kind. What does 28 say to us? Do 4 different numbers. Well, we're almost there. Represent the original number by n. Do what? Over here. Let's pick n for our number. Then what do? I add 7, so that would be n plus 7. Oh, let's change this to black, just so it's easier to see for the people online. Let's go n plus 7. Then times 3, so that would be n plus 7 times 3. Everybody follow that? Then minus 6, that would be n plus 7 times 3 minus 6. Everybody see what I'm doing? Then that would be all of that divided by 3. And then that would be all of this minus 5. You follow me? And want to see where I got this picture? I took n for the number, I added 7, I multiplied it times 3, change colors here again, multiplied it times 3, here's where I added 7, multiplied times 3, subtracted 6, divided by 3, and then subtracted 5. Now I just have to work it out. Well, that would be 3n plus 21 minus 6, all divided by 3, minus 5. What's 3n plus 21 minus 6? Is that 3n plus 15? 21 minus 6? Is 21 minus 6 15? So then I divide this by 3 and this by 3. So now I end up with n plus 5 minus 5. And what does that equal? N, of course, the number I started with. You say, I don't like that one. I don't blame you. It's too messy. But every now and then, the guy just wants you to put a letter in there and see the picture of what's happening. No matter what number you pick, you're going to end up with the same number you started with. Okay, that's enough of that. Let's move on to 38, because the rest of those are the same kind. So let's jump over to 38. There's a pattern relating to the length of a foot and the shoe size. Did you know that? If your foot is 9 inches, change back to red. If your foot is 9 inches, then your shoe size is 5. If your foot is 10 inches, your shoe size is 8. How did I get from 5 to 8? Add 3. How did I get from, if your shoe size is 11, if your foot's 11, your shoe size is 11. How did I get from 8 to 11? Add 3. Didn't I? So how will I get from here to here? Add 3. And how will I get from here to here? Add 3. And how will I get from here to here? Add 3. So if your foot's 12 inches long, what's your shoe size? 14. 11 plus 3. If your foot's 13 inches long, what's your shoe size? 17. And if your foot's 14 inches long, what's your shoe size? Everybody see where that comes from? Say, why did they do that? I have no idea. But that's just the way they do it. 30, number 40. Question number 40. What does 40 say? According to the Health Insurance Association of America, the average daily room charge for a hospital is as shown in the following table. In 1980, it was 127. In 1985, it was 212. In 1990, it's 297. What will it be in 1995? 5 years later? I don't know. Well, how'd you get from 127 to 212? Add what? What's 212 minus 127? Is that right? You got a calculator going there? 212 minus 127 is 85. What's 297 minus 212? 85 again. So what am I going to do to get to the next one? Add 85 again. And the next one? Add 85 again to that answer. You follow what's going on? So I just keep adding 85. And I don't know why it worked out like that. It just did. Well, there you go. What does it say? Stop doing homework when you get to 39. Sometimes I'll have you go on and do the stuff in other words and using your knowledge, but sometimes I won't. So I'll just tell you where to stop as we're working through the problems here. And it looks like we've used up most of our time. So we might as well stop with number 39, and that's it. Class is over. If you have any questions, I'll be around till I go to my 9:30 class. Glad to have you here this morning. Thank you for having a smile on your face in math class. I think some of you had some fun today. No. My granddaughter says, Poppy, they're not having fun. They're just laughing at you because you like math so much. Oh, come on. So how do I get this turned off now? What do I do? Let's try doing this. And then let's go down here and hit turn off now. Let's see what happens. Yes?
So if we get a question wrong, can we just, and then we go back and look at it, and we understand how we get it wrong?
Yeah.
Can we just write on the paper?
Yep.
Understand how
Yep.
I got it wrong?
You just write on. Yeah, if you miss one, you check it wrong, and then you go back and figure it out. You just put on the paper, I figured out what I did wrong, and you get credit for doing the homework.
Okay. Thank you.
And then I get my
So you just are in here all the time.
Do you want this slip of attendance?
Yeah.
Yes.
That looks so good.
Oh, thanks.
So for our homework, we just turn in paper, like notebook paper.
Uh-huh. Plug that back in.